Hey guys, welcome back to another video. This is Craig with 3D Resin Solutions, and if you're unfamiliar with 3D Resin Solutions, we are the creators of the Hero and Anti-Hero line of 3D printing resins where you can create your own custom color creations. We also distribute Uniz products, and that's what we're going to talk about here today. In this video, we're going to go over some of the amazing features that you might not know about in the Uniz software and some of the capabilities of the fastest desktop 3D printer available, which is the Slash Plus, and the Slash 2 is coming out here in a couple months. So without further ado, I'm going to start with two different files. Be sure to like, subscribe to this video if you hit that little bell notification. In future videos, I'll be printing what I make here today, or what I create here in these videos today are set up for print. I'll be printing them in a couple different manners, a couple different colors, and a couple different speeds to show off the speed of the Uniz and also kind of the functionality. It's got some cool features. For example, you might not have known that you can actually set different quality at different levels of a print. It's not just the whole print's going to be a 0.05, for example. You can do 0.1 to all the way down to 0.1 as far as the layer thickness goes. So yeah, let's talk about that. Let's jump right in. Be sure to follow me at Hero Resin on Twitter for all the updates, man. So today I'm going to jump into the Uniz software here, and this is available for download. Link down below. Also check us out at 3dresinsolutions.com or heroresin.com to check out our 3D printing resins. Once you download the software, we're going to go ahead and pull in our file. I'm going to start with a vase, so something more simple. All right, and I have my double spiral vase right here. Also, I apologize. My lighting's a little off, so the green screen might not be perfect, but it'll do for today's purposes. So the Uniz Slash series is extremely popular when it comes to dental resins and dental printing. For example, if you want to make night guards and Invisalign type of products for your teeth, those molds can be printed in about 10 minutes on a Uniz Slash Plus printer. So, and it'll print like 6 to 8 at a time. So 6 to 8 dental molds, 10 to 15 minutes is extremely fast printing. We're going to go over some of those features here in the coming videos. But to get started, so here's our vase. Couple things. So this is a hollowed out vase, you can see here. And if you wanted to print something like this, you're going to have to put it at a bit of a tilt, a bit of an angle. And the reason is because it's hollow. If you can picture maybe a cup printing, right? If this is our print, we were trying to print this cup. The build platform's like this, and it's going to kind of go up and down. What will happen is once these ends start creating, it's going to go down into the resin solution, and then when it pulls up, it'll create a suction. So if you create a suction, it has the potential to kind of pull it right off the build platform. So if there's any kind of suction created, you definitely want to put this at just a bit of an angle, and that suction will be removed. All right, so that's the first thing we're going to do. So right here to the left, we can do a rotation on the XY axis, and you can just very easily see how that works. All right, we're going to do the y-axis, and I think that angle should about do it. So we'll stick to 20 degrees. All right. So you can also do this little nifty button here. If you see this button, since we're going over the software features, maybe you're printing something more like a character, like the heroes or board game pieces and things like that, and you want him flat on the piece. Well, you can just do the align on the bottom, push that button, and then boop, click there, and you go right back to it standing upright. Okay, so that's the align bottom plane. Let's go back to 20-degree tilt. Okay, size. Of course, you have scaling options here. Don't mess with these unless you really want to change its orientation. You want it to be taller or wider or bulkier. If you want the scale to remain the same, you can scale it down 0.5, 50%, or of course you can scale it up, double the size, depending on the product that you're trying to print. I'm going to stick with 1. All right, so, and then I'm going to skip to inches because that's kind of where I, okay, that really blew it up. I have to. All right, so let's make some supports. So obviously it doesn't actually, I was thinking that when I pushed this button for a second, I kind of thought that it would translate it back over into inches, but no, it just took it and made it 85 inches tall. So you don't want to do that. All right, so moving to supports. Let's talk about some supports here. A few different options. The spacings, the diameter, the head type, head length, touch point size. These are all different things that you may or may not want to fool around with depending on how in-depth into the software you want to get. All right, if you're printing miniatures, something with very high detail, then you're definitely going to want to focus on the touch point size, make it as small as possible. You're going to want to increase the head length. So I'm going to go ahead and generate, and then I'll explain these things after it generates. And we can do a couple different options to show the differences. It's also worth mentioning that you really want to make sure that your piece is centered. So you want the weight evenly distributed across the build plate. If all the weight is over here, as it builds, it might have a tendency to tilt to one side. If that happens, the print will fail. So you kind of want to just try and keep the weight in the middle there. All right, anyway, so let's talk about our supports. So it generated some supports, and it's putting a number of these supports actually inside these little, which I'm not even sure how necessary that is. So if you want to get rid of those, it's very easy to do. You can simply click Edit, and we can just start deleting these. All right. So I'm just highlighting and clicking the delete button. All right. I don't think those are necessary in these. They'll be reasonably easy to cut out, but they do, wherever there's a touch point size in stereolithography, there's going to be a little bit of a blemish on the print. So I'm not going to spend all my time kind of going through deleting these, but just to show you very easily to delete them. You can also add if you wanted to add. So you got to find a spot where it's going to allow you to add a support. And let's see if we can zoom in and zoom out. Also, may sound elementary, but I'm zooming in and out with the ball joint on my keypad. All right. And then when I right click, when I hold, and then it allows me to move my field of sight there. All right. If I release and I click the standard button, then I can highlight. All right, so highlight all of these and delete. Right, super simple to do. In the meantime, see if I can find a spot. There we go. So I could add there. So I found a spot where it said, okay, you can add a support here, and I just clicked once, and it'll automatically add the support to the dimension sizes that I have. If I have all of these dimensions set to one size, for example, let's say I want all the mass majority of the supports to be maybe a larger support head, but then there's a couple details that I want to delete and replace with something smaller. So I can actually go in here and change everything I add from here on out will be a smaller diameter. I'm going to change the head length to as big as I can make it to kind of show that off, and see if I can't put one right next to a different size. So if I try and zoom in here, and see if I can't put one right there. Okay, so look at the difference of what I just created. So by increasing the head length, what I changed was the distance from the ball that's attached to the product and the joint here, this ball here. All right. So if we go ahead and we keep this, let's go back to a smaller size or a smaller head length, and let's increase the touch point size to as large as it'll go, and create another one. All right. So now you can see what we're changing here. The head length from the joint to the touch point is much smaller, much shorter, and the diameter has changed. So if we increase the diameter to as thick as we can go, we are increasing this whole size here. Let's go ahead and add one. Boom. Okay, so you can see how much more sturdy, how much stronger that support is. But the touch point size didn't change. So these are settings you're going to want to play around with. Couple things to take note of. Obviously, the larger the diameter of the support, the stronger that and sturdier that support's going to be. That's important when it comes to overhangs. So when we talk about overhangs, if I'm trying to print this stick that has maybe an arm here, right? I'm gonna have to put a support here. So if I put that support there, you're gonna want it rather strong because that support might have maybe 4, 5, 6 inches from where it started printing. So if it's too weak during the build platform is moving down, you have your support kind of here, and it's going up and down. If it's too weak, that pressure of it hitting the bottom resin tank might snap. Okay, if the support breaks, by the time it gets to where it's supposed to support something, it won't be there, and again, the print will fail. So when you're talking about things that need to be very long, and maybe the support is separated by itself, see if I can't create an example. So let's say I wanted to let's create an example here really quick. I'm going to see if we can't. Go back here and do a larger rotation. All right, so now what I'm doing is I'm creating an overhang. And I'm sorry, I noticed that I'm kind of sitting in front of this here. Let me see if I can't bring that over there. Okay, so I'm creating an overhang just for an example. Now I have an overhang. This is going to need support. So if I generate, make sure I exaggerate it. If I generate supports now, it's going to create a long support right here. Okay, quite a few of them actually. All right, that's also a number of insides. So this isn't how you want to print this, but for the example here, these long supports here, you're going to want to be sturdy. So these need to be hefty, because by the time they get to where they're actually supposed to support something, they have gone through quite a bit of a print process, and that pressure has been pushed on and pushed on and pushed on them. Now in this cluster of printing, in these cluster of supports, they're actually supporting themselves, but that's not always the case. All right, so that's what that means. So these touch point sizes, these are things you have to play with, and it's very dependent on what you're trying to print. Okay, so I feel like I beat that to death. Let's go ahead and go back to something that's going to be a little bit more printable for us. All right, sorry about that. So for some reason, like when I try to generate large supports on a large item, my audio gets all wonky. I don't know if I lose processing power or something along those lines. Maybe somebody can explain it to me in the comments or tell me how to fix that. So in the meantime, if it happens again, I apologize. Usually I go back and re-record it. But anyway, so I'm going to try and make this printable to something that we would actually use. So again, really quick, we're going to go back to our 20% tilt, all right, and I'm going to generate the supports by choosing my supports here. So I'm going to, if I really wanted to print this, I would stick with a probably 2.0 diameter. The spacing I usually do as large as possible. So the spacing between the supports, if I have a support here, or I can make them like this. Okay, so if you want to save resin, if you're resin conscious, that's one way to do it. Okay, if you separate, if you make the spacing farther apart, you generally need to increase the diameter. All right, if you put them closer together, you can make the diameter much smaller because they'll support each other. All right, so I'm going to increase the spacing 4 so they're not so close together, and diameter of 2 should be fine. Head length, I like the head length long, and I like the touch point small. I think I'll do 1 touch point. All right, so that's what I would generate, and I would go ahead and slice that and print it. But I'm not going to slice this because the audio is going to get all goofy again. So I'm actually going to go to a different project or a different print to show off all the slicer settings, which is where things get really cool and you get a lot of different speed settings. So yeah, I'm going to jump into that really quick. All right, so Hopefully my audio is still running strong here. Alright, so I'm going to open up this bear here. I printed this in another video, and I did it on the Anycubic. It's one of my kind of go-to pieces. I'm going to shrink it down just a bit. Again, just trying to save my computing power and my audio settings. So we'll be doing it with a smaller print here. But the settings won't change to what I'm going to do. So I'm going to go to the slicer settings. And here's what I want to show off. So I'm sitting in front of it. I'll move my camera over here. I'll be on the other side for now. So here's my guy that I want to print. And here's my slicer settings. And here's where the Uniz Slash series really is, kind of stands alone, I think, when it comes to DLP LCD stereolithography. So let's go over some of these settings. I'll be printing probably with the ZBS, Z-Abs green ABS plastic is what they try to basically replicate. ABS plastic is extremely strong. ABS stereolithography, if ever gets there, that'd be amazing. But right now it's not. So don't expect to be able to print ABS plastic. It's much more brittle, much weaker than that. But it does kind of mimic its features. So you can cut it, you can grind it. It's great for engineering type of things, prototyping. It's great for that. All right. Anyway, so first is the thickness. How thick do you want these layers to be? All right, 100 micron for something like this would give it nice definition. You can go all the way down to 0.01, which I mentioned all the way at the beginning of the video. At least I meant to say. I said 0.1, and then you can get all the way down to 0.1. But what I meant was all the way down to 0.01. All right, but 0.1 is very tight. So if you're into jewelry design and use wax casting and things like that, then you might want to get down to these really small layer sizes, because you're dealing with tiny little things and really high detail. So the Slash can absolutely do those things. But for this, 0.1 is cool. All right, so let's talk the exposure times. 3 seconds. 3 seconds exposure time, that's per layer. That's extremely fast. If you're dealing with an Anycubic, Elago, or similar type products, you're probably dealing with an exposure time something more like 10 to 15 seconds per layer. And the reason that the Slash can handle those high speeds is heat. When you take and you cure out photopolymer, when the UV light creates the reactions with the photoinitiators and starts linking the monomers and the oligomers together to create plastic, it also creates a lot of heat. So what Uniz did is they created a patented cooling process to dissipate that heat. Because it has that cooling process and that patented system built inside the printer, you can print much faster without destroying your print and potentially even melting pieces inside the printer. You can break a printer because of all the heat that's generated. So Uniz can get down to very low exposure times. You can even push this, if you wanted to, down to 2 seconds per layer if you really wanted to increase the speed, right? But if you change to, let's say, a Uniz Ivory, it kind of automatically changes the exposure time per layer based on the resin that you're using and based on the thickness, okay? So if I go to a smaller thickness, it won't need as much time exposure to cure out, because if the layer's not as thick, it won't need as much exposure time. Okay, so that's those kind of settings. Again, I'm going to go back to the ABS green. All right, and then I'm going to do a cooldown time. So what is the cooldown time? If I put the cooldown time to 0, what it's going to do is it's not going to give the resin any time to layer. So essentially, it's going to go down. It's going to print, it's going to come up, and it's going to go down. It's going to come up, it's going to go down. All right, it's not going to give any cooldown time. And so if I put the cooldown time to 2 or 3 seconds, it'll come up, it'll wait 2 or 3 seconds, and then it'll go down. The reason, again, it waits is to dissipate heat, but also it allows the resin to flow back underneath the print and get ready for the next layer. If you have enough resin in the tank, that's generally not an issue, but it is something to take note of. All right, so I'm going to put the cooldown time to 0 so I can increase the speed. What else can we do to increase speed? Glad you asked. Motor speed. Okay, motor speed is automatically set to auto, which I believe is technically medium to medium low depending. If I put it on high, all right, if I put the motor speed on high, it's going to move up and down very quickly. So not only is it going to not give me a cooldown time, but it's just going to keep going like this. All right, it's pushing the capabilities of the printer, but it does work depending on what you're trying to print. All right, and the rise height is something I don't mess with. So I could set the rise height. So not only is there no cooldown time, and not only is the motor running really, really fast up and down, but I can also say don't actually go up that high. Just go up a tiny little bit, right? I think you're asking for trouble if you start messing around with the rise height. I personally leave it at auto. If you want to play around, go ahead and play around with it. I think it's a cool feature. But you need to allow at least a little bit of time for the resin to flow underneath there. So just rising it up, lets the resin kind of go into where it needs to go in, and then come back down. All right, so that's that. Now, here's the one-of-a-kind feature that I think that's in the Uniz. So if I want to double-click right here, I created a partition, I guess you can call it a partition. And what I'm going to change is from here to here, right? This whole section here is just a base. I don't need it to be high definition. I don't need it to be very small layer thickness. So from here to here, I'm going to actually set my thickness to 0.3. All right, my exposure time will increase, sure, which again I can bring it down, but in the long and the short of it, there'll be fewer layers, so you'll save time. All right, so from here to here, the base is printed at a thickness of 3. All right, these settings here, and then from here to here, so the rest of the print I could do a setting, but actually I don't need it all to be that much. Maybe I only want the face to be really high definition. So, and again, this is just an example, but I'm going to go right here. Now that's where I really want high definition. So from there to there, I'm going to go all the way down to, let's say, 0.05 micron, or 50 micron, sorry, 0.05 millimeter. And I'll do, again, no cooldown time and auto height and high motor speed there. And then from here, the bulk of the body will print, I think I'm going to print it at 0.1, I think is probably a good definition, 0.15 maybe even. I do want to see the fur in the product in this particular print, right? Just as an example. So that gives you a functionality that really no other printer that I know of allows you to do. And if I'm wrong, please let me know. I'd look into it and I'll check it out. But either way, this is something that is very useful when you're printing. So it allows you a lot of functionality. So from here to here, it's going to print at 0.3. From there, the rest of the body is going to print at 0.1. And then when you get up to the head, it's going to print at 0.05. So you're going to have a higher definition where I want high definition. And of course, the definition gets less quality as it goes down, but it'll still look really, really cool. All right. So those are some of the features inside the Uniz software and the Uniz printers, the Slash series. So in the next video, again, if you like, subscribe, follow me at Hero Resin on Twitter. Links down below. Links down below to these prints too as well if you want to check these out. But in the next videos, what I'm going to be doing is pushing the limits. I'll be printing the vase, and I'll be printing it with the ABS green. Most likely, I might change it, but probably not. And I'll be using the ABS green to show off the speed of the Uniz Slash series printer. And then I'll be switching over to the Hero DLP resin. Again, that's the resin that we at 3D Resin Solution manufacture. And I'll be using that to create custom color vases to maybe match the decor of my house, something like that. Maybe I'll ask my wife, see if she wants something. And we'll go from there, just show off the capabilities of those things. All right, so please like, subscribe, follow. I appreciate you. If you stuck it all the way to the end, I really appreciate you guys. We're a new company. We're growing. We're all working really hard here to get off the ground. But yeah, I think we got some cool things coming up. So I'll see you soon.